series of differentiation in calculus. In today's video, we'll be looking at exponential functions. And I believe in our last video you saw the other functions that are listed in trigonometry. As when you differentiate exponential x, you get exponential x back. When you differentiate log x, you get 1 over x, and the rest. So for today's video, we'll be concentrating on exponential functions. Example 1. Differentiate the following. Given that y is equals to exponential x, that's number 1. Number 2, y is equals to exponential 2x. Number 3, y is equals to x squared exponential 3x. And number 4, y is equals to exponential minus x over x squared. To solve this, for example 1, number 1 is given to us to what? Y is equals to exponential x. In which case, from our table, the y dx for exponential x is the same as what? Exponential x. Okay. Now for number 2, y is equals to what? Exponential 2x. Now to solve this, I'm going to use function of function. Okay. In which case, I will say let u be equals to what? 2x. That's the power of our exponential. Let it be equals to 2x. In which case, the u dx is what? Is 2. So since u is equals to 2x, it implies that my y is going to be what? Exponential u. Okay. And from there, I can now say that was the y du will give me what? Exponential u back. Because differentiating exponential x, I get exponential x back. So invariably, if differentiating exponential u, I must get exponential u back. Finally, the y dx is what? The y du times u dx. That's this times this. That becomes 2 exponential u. Where u is equals to what? 2x. The y dx is going to be what? 2 exponential what? 2x. Now, a simpler way of solving this is by saying, since we have y to be equals to exponential x, what is the coefficient of the power of x? It is 1 in this case. So differentiating exponential x, I'm going to get 1 times exponential x. Okay, that's the coefficient of this power up here times exponential x back. That's the simplest way of differentiating exponentials. The same thing for 2x. Differentiating exponential 2x, in that case, is going to be what? 2 times what? Exponential x. Exponential 2x in that case. Okay, which becomes what? 2 exponential 2x. Okay, which is our answer here. So applying that simple step makes you able to solve questions easily in exponential. But for this example 3, y is equals to what? X squared exponential what? Minus 3x. So for this case, I'm going to be using what? Product rule. Okay, because we have two different functions of x. That's x squared and what? Exponential what? Minus 3x. For number 3, with the idea of product rule, formula is what? V du dx plus what? U dv dx. That's the y dx. Okay, the y dx is equals to this formula. Where our v is what? Exponential what? Minus 3x times du dx. That we are going to differentiate u. Our u is what? X squared. Differentiating x, so I'm going to get that what? 2x. Plus, what's my u? My u is what? X squared times dv dx. In this case, okay, we are given exponential minus 3x. So as I explained earlier, it becomes what? Minus 3 times exponential minus 3x, which becomes what? Minus 3 exponential what? Minus 3x. So the y dx now becomes what? 2x, bring it to the front, exponential minus 3x plus what? Now, plus and minus becomes minus. Okay, minus 3x squared exponential what? Minus 3x. In which case, the y dx is equals to what? You can bring x exponential minus 3x out, and something that is common. What remains? 2 minus what? Minus x. Okay, where you bring x exponential minus 3x here, it means 2. You bring x exponential minus 3x here, this is gone. This one, just one that is moved out of that. Then it means minus 3x. Okay, now for example 4. Example 4 is what? Is quotient rule. In which case, this is my u, and this is my what? My v. So for that question, the formula for quotient rule is what? The y dx equals what? V du dx minus u div dx over what? Over v squared, where the y dx is equals to, my v is what? X squared. Du dx, this is exponential minus x. That becomes minus 1 times exponential minus x, because coefficient of exponential minus x here is what? Minus 1. The coefficient of minus x here, is what? Minus 1. That becomes minus exponential minus x. Okay? Then minus u is what? Exponential minus x times dv dx. This is our v, so the differentiating becomes what? 2x. Okay? That becomes 2x over v squared. Our v is x squared. So that's x squared all squared, which is x to the power what? X to the power 4. So the y dx now becomes what? X squared minus x squared exponential minus x, because of this minus that is there. So plus minus times, if it's so plus becomes what? Minus exponential minus x. Okay, then this is still minus exponential what? Minus x times 2x, or we can bring 2x to the front, which becomes what? Minus 2x exponential what? Minus x over what? X is power what? 4. Now, bringing what is common out. What is common is what? What is common is what? X. Okay. X is common in the two of them. Exponential minus x is also common. And that should be all. So what remains? Okay, what remains? You can bring minus out with it. What now remains is what? X. Okay, this is gone. This becomes plus because I brought minus out. Plus 2 x plus 2 over x is power 4. Finally, this can remove one of that, it remains 3. So we now have what? Have an answer to what? Minus exponential minus x, okay, into x plus 2 over what? X cubed. So that's how to differentiate in exponential function. So in our next video, we will continue with logarithmic functions. In which case, I'm going to also use logarithmic functions to what? To solve questions in differentiation. Please do also subscribe to my YouTube channel if you do not subscribe, and put on the notification button so you can receive notifications as we upload our next videos.